Hi everyone, and welcome to our second lesson of Our Violent Planet. We are now going to be looking today at tectonic plate boundaries. So the plate boundaries is where the plates meet. So you can see the lines here. We have many different, the large and the small plates meet in. When they collide, or they don't collide, there's many different ways that they move around the crust and on top of a certain area called the mantle, which we're going to look at in 2 slides time. So please pause the video, write down plate boundaries, and then press start. Okay, so moving on. Objectives. All pupils will understand the interior and exterior structure of the planet Earth. Most pupils will be able to describe each plate boundary. Some pupils will be able to give examples of each plate boundary. So what I want to introduce first is the interior. So that's the inside of the Earth. So from the inside out, what does our Earth look like? The first part we have on the outside is the crust. This is what we've been looking at. This is where our tectonic plates are. This is where we live, our land, our oceans. Proportionally, so that's in comparison to the rest of the world, the crust that we live on is the same thickness as the skin of an apple. So it shows how big our Earth is compared to how the height and the size of the crust can be that protects us from an area called the mantle, which is a layer of molten rock. Underneath the mantle, you've got the outer core. So as you see, we've got the crust going on the edge. You've got the mantle below it. This is where our plates kind of float on and move around. And then we've got the outer core, which again is molten rock and starts to be some metal. And the inner core, which is thought to be nickel and iron solid. It's over 5,000 degrees when you get to the inner core. This is quite a basic diagram of what I want you to do. Again, if you are not an artist like myself, you can just do a kind of half image where you draw a semicircle and make it smaller and smaller. Just please make sure you annotate correctly the crust, mantle, the outer core and the inner core. So just to run it through, we all live on the crust. This is where we find our land and oceans. The mantle is that layer of molten rock which all the tectonic plates are moved around with and float on top of. And then you have the outer and inner core. So extremely hard core of our Earth. So if you could please pause the video and copy this diagram into your books and then press play when you're ready. Okay, so we live on the, just a reminder, we live on the Earth's crust. The crust is split into huge slabs of rock called plates. These plates are moving very slowly as they float on the molten rock of the mantle. So this is we're now today going to look at what happens when they move away from each other or when they collide. So it's building on last lesson. We now know the Earth is all these different plates, and we now know they're on top of the mantle and they almost float on top and they move around very slowly. So before we start, underneath this PowerPoint will be the resource sheet in a PDF form. If you want to print it out and work on that sheet, that's absolutely fine. If not, could you get a plain A4 piece of paper, it could be plain, it could be in your book, and divide it into 4 sections, because you're going to be looking at 4 different plate boundaries today and what happens there. Each will need a diagram and some detail, so it's essential that you have that prepared before we start. Regarding the research, there are going to be 2 different ways to research these points. I am going to be speaking for each plate boundary, and you can take the information there, or because you're at home, you can also research the plate boundary yourself. So I'm just going to work through each plate boundary. Whenever you need to pause, and I'll try and give you hints when you should pause, carry on and then replay the video when you want to listen some more. So the first one we're going to look at is a constructive plate boundary. As you can see the animation, it's when the plates are moving apart from each other. And I'm going to go into detail now on why we call it a constructive plate boundary. Constructive plate boundary is where 2 plates move apart, and this is due to something called convection currents making this movement, as you see here, rising up from the inner and outer core, where it'll be extremely hot. It rises up till it reaches the plates and it begins to cool. As it cools, it starts to drop, so it changes direction. It then starts to drag the plates away from each other. This opens a gap here where you will find a lot of the molten rock in the mantle will rise up to the surface. And what we know with molten rock is when it cools, it becomes solid and it creates new land. So where these convection currents are continuing down and they start to move towards each other, they are actually dragging certain plates down underneath a different plate. So moving on, constructive plate boundary. Like I said, this is an image you will find on your sheet or you need to put into your book. The three questions I have: in which direction are the plates moving? What is happening in between the plates? Where in the world would you see this? So again, they're moving away from each other. What is happening between the plates? Convection currents are dragging them across, leaving the opportunity for molten rock to rise. It reaches the top, and there you can create new land as it starts to cool. And where in the world would you see this? Iceland. Fantastic opportunity that we had in 2020 and hopefully in the future to go here and see these constructive plate boundaries. As you see the issues we can have, some can create land, but also you can create volcanic activity. As the plates move apart, there can be explosions of molten rock, which we then know as lava. So that's the image you will need to copy in your book, and there are three questions you need to answer. If you want to pause and you can move back and forth the video, that's great, or you can add your own research. So directions moving apart, I've explained what is happening between the plates, and I've given you an example of where in the world. So you can now pause the video and fill that out. You can also use the internet for any further research you want to do. When you're ready, please press play and we'll move on. Okay, on to our next plate boundary. Here we have destructive plate boundary. This is where an oceanic plate meets a continental plate. So a continental plate is known as an area that has land on it, and the oceanic has ocean on it. What you start to see here is this oceanic trench goes under the key term is subducted under the continental plate. This is one because the oceanic plate is heavier. It's a heavier plate with the ocean on top of it, so it subducts and pushes it under, and also because of the convection currents we looked at earlier can affect it and drag it under. As it begins to drag into this mantle, it begins to melt. The temperature increases and this solid rock starts to become the magma and the molten rock we looked at earlier. As this starts to build up, it creates something called a magma chamber. And this magma chamber builds up of more rock, more molten rock, and more molten rock till it can't hold it anymore. It then finds its way to burst through the continental plate, and this is where we get volcanoes. So the magma heats up here, a lot of pressure is provided, and then it up through the main vent and it explodes out of a volcano. And that is one of the usual ways we see volcanoes are created. Again, it's not creating new land, they'll create these volcanic landscapes and you might get some explosions. So in this, the direction they're moving is towards each other. We've gone through briefly what is happening when the plates meet. There are many different things that we look into more detail if you take geography for GCSE, and we look at the trenches that are created, we look at mid-oceanic ridges, with constructive, but for now, just simply, they collide, they move together. Try and use the key terms. The oceanic is subducted under the continental plate, begins to melt because of the higher temperatures, becomes molten rock, creates this magma chamber, and then it moves on to explode through the main vent of a volcano. Where in the world would you see this? And Japan, which is on a destructive plate boundary, which can give a lot of problems, such as earthquakes and volcanoes from these two plates colliding. So you can use your own research as well. Please pause the video and then press play when you're ready to go on to your next plate boundary. Please remember, each section needs a diagram as well. Okay, moving on. So now we have a conservative plate boundary. This is where plates might be going the opposite way or the same alongside each other, but they're not colliding as such or moving away where they create new land or volcanic activity. What you have here is this plate's coming at a bit more of an angle than this plate, and they are colliding. But it's conservative, nothing's being destroyed. They're just moving along together very slowly. The issue you might have is something called faults. It's when these two collide and maybe one is going slightly faster than the other, and this one gets dragged in and the pressure builds up till it slips, and then suddenly that's where we get our largest earthquakes. So the conservative plate boundary is a real issue of creating earthquakes in some areas, such as San Andreas Fault in California. Okay, you can see from here the earthquake damage that is caused when these two large plates are moving in the same direction, but there can be something called a fault, where one might be moving faster than the other, or it might catch itself till it slips or moves backwards slightly, and then that creates enough vibrations and tectonic activity to cause an earthquake. So they're moving alongside each other. I've given a brief explanation of what happens where the plates meet, so you can put bullet points, so you can put a paragraph of that, and you can also include your own research. And then where in the world would you see this? We've said San Andreas Fault, California. Okay, so you should pause the video, finish that, and then move on to the collision plate boundary when you're ready. Okay, the collision plate boundary. This is where you find continental crust and continental crust colliding. The plates start to collide together, and what you find is, because they are similar weight, one will be subducted under, but it will, rather than go deep down and start burning the mantle, it will start to push the other continental crust up. And as it pushes the continental crust up, it begins to fold and create a mountainous range. As you see the edge of this continental crust, you can see the mountains where the plate has been pushed up. Okay, so they collide, they're going in the same direction. One plate goes under and it's subducted under, and it starts to push the other continental crust up, and that's where you get these fold mountain ranges. The most classic place you see in the world is the Himalayas. A good example of this is where you're seeing a collision with Asia and India itself, where you can imagine 71 million years ago India might have been down here, and it starts to moving back, and the more it collides, the more it's pushing up these mountain ranges. Some fantastic images here you can see from space. Here are the mountain ranges I've been talking about. So that's the Himalayas, where you find Mount Everest. That would be an example of where you'd find collision plate boundary. So you'll need to put in your sketch what direction they're going and where in the world you will see this. Once you're finished, please resume the video, but for now, pause it, get the diagram done, and answer the questions. Okay, welcome back. So, just to finish off, we've got our collision plate margin, constructive margin, destructive margin, and conservative margin. Okay, our plate boundaries. So the first one is where the two plates, both a continental crust, meet, they collide, and the continental crust is forced upwards. This forms mountain ranges like the Himalayas. Earthquakes are common here also. When convection in the mantle pulls the plate apart, it forms a constructive plate boundary. Where plates are moving apart, magma wells up between them. When it erupts, it then cools to form new crust. This is where, and then back to the conservative, where two plates slide past each other. Crust is conserved, it's neither destroyed or made. earthquakes are common here. Example, San Andreas Fault. You might see in the film. When two plates meet, the oceanic crust is subducted. That was our keyword we looked at earlier, under the continental crust. Friction melts the oceanic crust as it sinks into the mantle. Molten rock then rises, burning through the continental crust, and a volcano erupts at the surface. Double check your work to these 4 points. Make sure you've got every bit of detail and you've got the location and what direction the plates are moving. If you check against that slide, please check your own information. Once you've done that, that's you've done for the lesson. Well done. We now know our 4 plate boundaries or plate margins, and we can move on to our next lesson to start and look at volcanoes, earthquakes and tsunamis. Thank you very much. Thank you for listening.